Hello, welcome to this new assignment of this new course. Today we're going to explain continuous aerobic capacity and field tests. It's a comparative analysis of the beep test, the Cooper test, and the maximal aerobic speed tests. This is for the King's College Master's Program on Sports Science and Performance, and I am Mariano Quesada Saborio. So why test aerobic fitness or capacity? Basically, because this is a performance prediction, the aerobic power, VO2 max, and the capacity, maximal aerobic speed, and efficiency are primary determinants for endurance success. This helps you out in a training prescription. Convert field test results directly into precise training zones like intervals at 100 and 110% of the maximal aerobic speed, tempo, like tempo runs at 80 or 90% of the VO2 max, velocity VO2 max, monitoring and talent ID. These track physiological adaptations over macrocycles, identifying talent benchmarks and assess readiness for return to play in any case, and also helps for test selection criteria. You balance scientific rigor, validity, and reliability, as it was said in the class, with practical constraints like logistics, large groups, specific movement patterns, so on and so forth. So the overview of the three tests would be the beep test, is a 20 meter multi-stage fitness test. The protocol, it's progressive 20 meter shuttles with increasing speed levels. What's the goal? Run until volitional exhaustion or failure to meet beep. What's the primary output? Level reach and estimated VO2 max. The Cooper test is a 12-minute run. You run as far as possible in exactly 12 minutes. Typically, it's located on a 400-meter track or measure flat loop. And primary output is total distance in meters and estimated VO2 max. The maximal aerobic speed test, FEMEVAL, and the time trials. It's a continuous and incremental track or a set distance, like the time trial. Determine the minimal speed at VO2 max, and the primary outputs will be maximal aerobic speed for interval prescription. Now on the beep test, the protocols and the outputs. The standard protocol, how's the setup? You mark two parallel lines exactly 20 meters apart on a flat, non-slip surface, and the participants line up behind one line. You start the test beginning at level 1, which is around 8.5 kilometers per hour, and you have an audio cue, which is the beep, that signals when to reach to the opposite line, and the progression, the speed increases by 0.5 kilometers per hour approximately every minute at each level, and shuttles become faster and recovery time decreases. Turning most touch or cross the line before the beep sounds, pivot and return immediately. This is very important because this test also examines your neuromuscular demands and capacity. It's well used for sports like basketball, football, soccer. You can use it also for combat sports like MMA, where you have to use like your neuromuscular endurance plus the aerobic capacity. So what are the key outputs? The primary score is the final level and shuttle. Velocity would be the velocity max, kilometers per hour. Physiological is your heart rate peak, beats per minute, and the capacity, the estimated VO2 max. Here you can see the speed progression in kilometers per hour. The termination criteria is when the athlete fails to reach the line before the beep on 2 consecutive occasions or voluntary stops due to exhaustion. Here is the Legrand-Lambert prediction equation. But this, the VO2 max is equal to 5.857 times velocity max minus 19.458, where velocity max is the speed at the end of the final completed stage. Physiology and performance drivers. The metabolic dominance. It's predominantly aerobic, and it's progressively taxing the oxidative system until reaching the velocity VO2 max. Is the velocity at VO2 max near final stages. The change of direction cost. Every 20 meters significantly increases the metabolic cost. Acceleration, deceleration, and cycles create energy spikes compared to constant straight line running. The performance equation. Success depends on combination of high aerobic power plus high running economy plus efficient turning mechanics. Validity and reliability. Criterion validity is 0.84 correlation versus lab VO2 max. It's moderate to strong correlation with direct treadmill measurements in adults. The change of direction efficiency creates noise, potentially underestimating aerobic power in poor turners. The standard error estimate ranges from 3 to 5 milliliters per kilogram per minute, depending on the population. The test reliability is 0.95 on a standardized groups. Is high reproducibility when protocol is strictly standardized. Variability, typical error increases with different surface, footwear, or audio clues. Strengths, scalable, can test large groups simultaneously. Low cost, requires only cones, tape measure, and audio file. Normative data, massive global database for comparison across sports. And pacing, audio cue removes pacing guesswork for novice. Limitations, heavily penalize change of direction bias, which heavily penalize athletes with poor turning mechanics. Surface effects, grass versus court, significantly alters energy cost. The learning effect, familiarity with the timing turn improves score without fitness gain. It's like cheating. And indirect predictive equation is not direct physiological measure. The Cooper 12-minute run protocols and output setup is basically a standard 400-meter athletics track or flat. It's measure, of course. Markers every 50 to 100 meters assist with distance calculation. The participants run, walk as far as possible in exact 12 minutes. Pacing strategy is crucial for valid results. Standardization requires 10 to 15 minute warm up. Group starts must be managed to avoid crowding, and lap counting is essential for the test. After 12 minutes, you stop immediately. You record the laps plus the final partial distance to near 10 meters. You need like a pacing guidance. The goal is maximal distance. Athletes should aim for an even maximal steady state pace rather than sprinting and fading. The key outputs, the primary score is the total distance, the velocity is the average speed, category, fitness norms, and the capacity is the estimated VO2 max. You have the predictive equation done by Cooper in 1968. VO2 max is equal 22.3 351 plus distance in kilometers minus 11.288, where the distance is the total distance covered in kilometers. The physiology and performance drivers. Severe intensity domain operates in severe intensity domain where with progressive VO2 slow component drift, reaching the VO2 max near the end at 12 minutes. The efficiency and environment, minimizing the turning cost of change of direction compared to shuttles, is highly sensitive to running economy and external factors like wind, heat, and surface friction. The race specificity, it's better translation linked to actual race performance, test, sustain aerobic power, mental endurance, and the ability to manage lactate accumulation. The pacing skill is critical for max distance, the aerodynamics, you have to take that into account, and the mental toughness to sustain this comfort. The validity and reliability, 0.9 correlations, ranges from 0.85 to 0.95, is a strong correlation with a VO2 max in healthy adults. Running economy and pacing skills significantly influence the distance covered, improving its predictive power for race performance. Basically, the standard error estimate is 3 to 5 milliliters per kilogram per minute, depending on the sample fitness level. The reliability is high. Excellent reliability when environment conditions and course surface are standardized. Pacing familiarity improves score stability. Strengths, simplicity, minimal equipment needed, just a stopwatch and track. Direct data provides average speed and distance directly usable for training. Low cost, can test huge groups simultaneously with minimal resources. Specificity mirrors steady state endurance demands. What's the limitation? The environment, as we already said, that can affect the distance covered. The pacing errors, novice will often start too fast. Marshalling track laps for large groups can be challenging. And motivation, maximal 12-minute effort requires high mental drive. Standardization checklist. Measure 400-meter track. Standardized warm-up, consistent verbal encouragement, neutral weather conditions, pacing start strategy guidance, and accurate lap counting. Maximal aerobic speed is the minimal running velocity that elicits VO2 max. It represents the upper limit of the aerobic system's power. The testing modalities is the variable, incremental continuous track test is the gold standard field test. The time trials is the 1500 meters or the 2 kilometers maximal effort runs used to estimate maximal aerobic speed. The primary outputs are the direct measure of the MAS and velocity peak. Optional VO2 max estimation via metabolic cost formula, the Leger and Mercier, and training application is essential for prescribing high intense interval training. The typical prescription ranges from 100 to 120 of the MAS for short intervals. Here are the key estimations. VO2 estimation is 3.5 times speed, and the MAS from time trial distance divided by time. The unit conversions is kilometers hour to miles per second divided by 3.6 and miles per second divided 2 kilometers per hour. It's times 3.6. Why the MAS, unlike VO2 max physiological ceiling, MAS integrates running economy, making it more practical for metric for prescribing running speeds and in training. As the protocol for the VAM Evo protocol, you start beginning at 8 kilometer audio signals coordinate space. The progression increases by zero point 0.5 every minute, just like the beep test. The cones are placed exactly 20 meters around the 400-meter track. Determination: failures to reach the next cone by the beep on 2 consecutive occasions. Advantages: direct MAS provides highly accurate maximum aerobic speed for training prescription, strong, strong correlations with lab VO2 max than shuttle tests, no change of direction bias, and the group testing is efficiently test large squats simultaneously on standard track. What are the disadvantages? Equipment needs, you require 400-meter track, precise cone placement, and quality audio system. Pacing skill, adjusting stride to 20-meter markers requires practice and familiarization. Environmental, again, it's susceptible to wind and weather conditions. Space cannot be performed in indoors or small facilities easily. The 1500 2-kilometer time trials protocols, pros and cons. Test protocol: cover a fixed distance, 1500 meter or 2 km in the fastest time possible. MAS calculation is distance divided by time, simple and direct. Energy systems: 1500 meter has a higher anaerobic fraction, between around 15 and 20%. The specificity: the 2 km is closer to 5-6 minute window, ideal for velocity VO2 max duration. Advantages: simplicity, minimal equipment needed, stopwatch measure track, no audio cues required, gives immediate average data for MAS estimation, highly relevant for middle distance runners and track athletes, allows athletes to use their natural pacing strategy. What are the disadvantages? The pacing sensitivity, it's motivation dependent also, and anaerobic inflation. Anaerobic kick can underestimate the true aerobic MAS, especially in the 1500 meter test. It's also hard to test large groups simultaneously without individual timing chips. MAS validity and evidence. Bias, protocol bias, overestimation versus lab plateau. It's basically the underestimation. The time track and 1500 meter time trial significantly overestimate the MAS compared to the gold standard lab plateau method due to the anaerobic contribution. The validity, okay, confirm MAS must represent the lowest speed eliciting VO2 max with minimal anaerobic cost. Short time trials often fails in this criterion. Practical recommendations: prefer protocols use a straight line incremental test or 6 minutes time trials for highest accuracy. Training prescriptions: beware of the protocol dependent bias. If using 1500 meters, adjust intensity targets down slightly. Interpretation: consider standard error of estimate when calculating the percentage of the MAS intervals. Running economy: why same VO2 max, different score? Definition and impact. Running economy is the oxygen cost, milliliters per kilogram per minute, to maintain a specific submaximal running speed. Better running economy means consuming less oxygen for the same speed, allowing for faster performance in the same physiological efforts. What are determinants of the economy? The biomechanics, muscle tendon stiffness, stride length, frequency, vertical oscillation, posture, and efficiency. The metabolic, muscle fiber type distribution, type 1 versus type 2, mitochondrial density, and substrate utilization. And the test specific change of direction technique penalizes poor turners in beep test. Pacing skills impact in the Cooper test. Same engine, different car effect. Athlete A, the gas guzzler, VO2 max 60 milliliters per kilogram per minute, economy, poor, high cost. Athlete B, the hybrid, VO2 max 60 milliliters per kilogram per minute, economy, good, is a low cost. Performance outcome, athlete A, 16 kilometers per hour versus athlete B, 18 kilometers per hour. Athlete B runs 12.5 faster despite having the same aerobic capacity. Practical application and sport selection for these tests. The BIP test, as we said, they're pretty good for team sports with change of direction needs, like soccer, rugby, MMA, basketball. School and large squad screening and limited space. The Cooper test for endurance athletes, triathletes, military, law enforcement, simply monitoring without equipment. The mass test, they're best for middle distance runners, field sports needing interval prescription, performance programming, the percentage of the MAS. So test selection decision tree, start needed aerobic test, needed percentage of the MAA zones, no, sport specificity, endurance, equipment, minimal, Cooper test. Audio okay, group size small or large, small, MAS test, it's better, large, beep test. Sport specificity, intermittent, beep test. Need a percentage of MAA zones? Yes. Track available? No. Beep test or 30 to 15 IFT? Yes. MAS test. Here are some training prescription examples like pace, extensive aerobic, 10 to 20 minutes continuous bouts, 60 to 75% MAS, the tempo threshold, 80 to 90 MAS for 10 to 20 minute bouts on a steady state. VO2 max interval, long, you have 4, 6 times 3 to 5 minutes with 1 to 2 minutes recovery. The short will be a 15-15 at 100% MAS. You can work it on 100 to 105. And for speed endurance, short reps, 110 to 120. This is the comparison table that I put it with the Beep Cooper and the MAS test. The protocol, we already discussed what the protocol are as the primary output, VO2 max level on the Beep test, distance, and MAS on the MAS test, estimates VO2 max indirectly equation, VO2 max via distance equation, and MAS velocity VO2 max direct. Validity versus lab, 0.80 to 0.90, affected by change of direction economy. Cooper test, 0.85 to 0.95 is a high for endurance runners, and MAS test is high, protocol dependent accuracy. Reliability, BIP test good, Cooper test high, and MAS test high. Pros, BIP test scalable for large groups, low equipment. Cooper, very simple protocol, direct endurance measurements. MAS test prescriptive, is scripted, sport-specific variants. The cons, we said, change of direction, psychological quick point, pacing strategy sensitive, weather, impact, also requires specific setup on the MAS test and anaerobic inflation. We already discussed that this BEP test is better for team sports, schools, general screening. Cooper would be for endurance athletes, military, law enforcement, and MAS test for runners, field sports needing interval prescription. And these are the references that I use to make this presentation.